Keeping up with our motto that learning be a joy and teaching a pleasure, here we are with the remote teaching and learning process to bridge the gap. Happy learning, students. Let us continue with Chapter 10, Force and Types of Force. In the previous session, we have discussed three forces, namely muscular force, mechanical force, and gravitational force. In today's session, we are going to discuss magnetic force and frictional force. Let us start with the magnetic force. The force exerted by a magnet is known as magnetic force. Here in this picture, you can see a horseshoe magnet. When it is brought near an iron nail, the iron nail attracts towards the magnet and sticks to the magnet. In this picture, you can see an iron pin is attached to a string, and when this pin is brought near the magnet, this is the magnet cube. So when this pin is brought in the vicinity near the magnet, the pin is getting attracted towards the magnet. So this force exerted by the magnet is known as magnetic force. Here again in this picture you can see when the horseshoe magnet is brought near the iron pins are getting stick to the magnet. Now, this picture shows the magnetic field of the magnet, the area near the magnet around which you can see the lines. This is the magnetic field. When a magnetic object is brought near the magnetic field, the magnet exerts a force on it and that object is getting attracted towards the magnet. So this force exerted by a magnet is known as magnetic force. You all must have played this game. Which game is it? Yes, carom. When a carom piece is flicked lightly, it slides over the carom board but stops at a certain distance. In this picture, a ball rolling over the flat ground stops at a certain distance. Why does this happen? It is because of the frictional force. Let us understand what is frictional force. When two surfaces rub against each other, the force of friction comes into play. Here, the two surfaces are the one which is purple in color and the other one which is green in color. So when this purple object is pushed, it will slide over the green object. So the direction of pushing is towards the right, but the force of friction is going towards the left. Frictional force always goes against the direction of motion. Let us see with the help of this example. The force of friction is opposite to the direction of motion. Here the person is trying to move the trolley towards the left, but the force of friction will be acting towards the right. The three instances of riding a bicycle are shown in this picture. In the first one, when the force is applied on the pedal, the bicycle will move. If that force which is applied on the pedal is more than that of the frictional force, then the speed of the bicycle will be more. That is, speeding up will take place. Here you can see the red arrow is a shorter one. It indicates the frictional force, which is in the direction opposite to that of the motion. Whereas this blue arrow towards the right shows the force from the pedal. So if force on the pedal is more, the length of the blue arrow you can see is more. So if the force which is applied on the pedal is more than the frictional force, then the cycle will speed up. Whereas in the second one, you can see both the forces, the red one which is the frictional force and the blue one which is the force on the pedal. If both of them are equal, the size of the arrow indicates that both the forces are equal. If both of them are equal, then the cycle will be in steady state. That means it won't move. It will be in the rest position. Whereas in the third case, if frictional force is more as compared to the force from the pedal, then it will reduce the speed of the bicycle. This is what happens when the brake is applied while riding a bicycle. It stops after running a short distance. How does the brake work? Between which parts is friction produced? Here you can see in this picture, this is the tire of the bicycle and this is the brake. So you can see over here, when the brakes are applied, the surface of the brake as well as the tire, they are rubbed against each other and frictional force is generated, because of which the motion of the bicycle is getting stopped. Okay students, now try this at your home. Take 2 pieces of smooth paper and 2 of sandpaper and rub them against each other. What will you notice? The smooth surfaces can be easily rubbed against each other because the force of friction between them is less. While the rough surfaces, they cannot be easily rubbed against each other because the force of friction between them is much greater. And this is the reason that it is possible for us to walk on the ground only because of the force of friction. If there is no force of friction, we would slip and fall. For example, we are likely to slip while walking on an oily or a wet floor. As shown in this picture, the boy is likely to slip while stepping over a banana peel, because when banana peel comes in between the foot and the surface of the ground, it reduces the force of friction, and because of which the boy will fall down. Here in this picture you can see the person is sliding over the ice, and here the person is sliding over the grass. Now ice is very slippery and having a smooth surface. So when the person is sliding over the ice, the motion will be very smooth because the force of friction will be very less. Whereas when the person is sliding over the grass is not that smooth as compared to the ice. So the motion will not be that smooth and fast as compared to the motion of the person over the ice. Now in the third picture, you can see over here there is a wooden plank. With the help of wooden plank, there are 2 people who are trying to pull out the car which is stuck in the mud. So why is a wooden plank laid down for pulling out a car which is stuck in the mud? A force of friction is generated between the wheel and the wooden plank laid down under the car. Hence, it can be pulled out from the mud. In short, The force of friction can either be decreased or increased as desired, and both of them are helpful. If there were no friction, it would be easy to pull or push large heavy objects across the floor. In absence of friction, it will be very easy to pull or push even the heavy objects, because frictional force is always opposing the motion. So if the frictional force is not there, it will be very easy to move the heavy objects from one place to another. If there were no friction, you would not be able to walk, as explained earlier. Your shoes will not grip the ground and you would slide. Friction is useful. How? Ice causes very little friction, which is why it is easy to slip over an icy day. But this is a good thing for ice skating and sledging, because less frictional force makes ice skating and sledging easier. This is all about this session. In the next session, we will cover the remaining two forces, that are electrostatic force and combined force. Thank you so much.